So let me know once you're able to see my screen.
Visible. Oh, time to
Yes.
distance. I do not like this chapter. Work and time.
And work time.
Work and time.
Yeah.
Yeah.
So we'll make it, see, the whole point is that instead of, trying to tackle the problem in its own specific ways, it's better to follow some generic frameworks which will help you solve most of the problems, right? So that's the whole point. So let's get started with this. Okay.
Mhm.
We'll start with work time and then we'll go to time, speed, distance. Or you want to first do time, speed, distance? Tell me.
Anything so, whatever works.
हाँ वर्क टाइम करते हैं थोड़ा वार्म अप करते हैं फिर टाइम स्पीड डिस्टेंस थोड़ा सा ज्यादा डिफिकल्ट होता है
Hmm.
लेट मी ऑल्सो पुल अप द क्लॉक okay now what I'll do is let me you can just attempt this just read it don't attempt it just read it and then I'll solve it for you.
Oh no. Okay. Machine A, B, and C can work at a constant rate. B does it in 75 minutes. B does it in 50 minutes. Yeah, there was a way of solving this.
Yeah, so there are two ways of solving this, okay?
Hmm.
And with these two ways I'm going to introduce two generic methods to solve work time problems. Almost all work time problems can be solved using this method. This method is as simple as time, speed, distance framework. It's similar to that. So can I say distance is equal to speed into time?
Yeah.
Similarly, work is equal to efficiency into time, where efficiency is similar to speed and work is similar to distance.
Okay.
Yeah. So this first equation is giving us time, speed, distance problems. Second equation usage is for work time problems. But in a sense, both are trying to do the same thing, where there's some speed or relative speed, you multiply that with time and you end up getting work done or distance, right? Now, we would want to put everything in this format, whatever is given to us in terms of data. So let's do it for this problem. Method one I'm going to show right now. Method one, method two, both use work efficiency time method, which is this equation, but in a slight different way, right? Then you can see what works for you. So I'm going to write work efficiency time on top. And let's start doing this. Machine A can complete the job in 75 minutes. So can I write A here? And can I write 75 here?
Yeah.
And also it's useful to write the units on top. So A can do it in 75 minutes. Can I say complete job? So can I write work is 1?
Yeah.
And then working alone, B can do it in 50 minutes. So I'll write it 50 here. And can I say the same work? 1.
Yeah.
Working together, A, B, C together can do the same job, which is work 1 in 10 minutes. So this is what is given to us, right? Simple application of work equal to efficiency into time. You can calculate speed or efficiency very easily. That is work divided by time. So on top, you can just write this. So it's easy. So efficiency is work divided by time. So can I write 1 by 75, 1 by 50, and 1 by 10? It means that in 1 minute, A does 1/75th of the work. That is what it means. Yeah. So this is work by time in terms of minutes.
Okay.
So we have A's efficiency, we have B's efficiency, we have ABC combined.
So
Now,
A plus B plus C is 1 by 10.
correct. A plus, so this is nothing but A plus B plus C efficiency
Okay.
is 1 by 10. We know the efficiency of A is what? This. So let's write E of A is what? 1 by 75 plus 1 by 50. E of C is not known. Okay. But we can write C. We can write work 1 for C and we can write time T taken by C. So can I say efficiency for C will be 1 by T, correct? And then efficiency of C, I can write 1 by T.
15.
Yeah. And then we can find what is T.
15, no?
Yeah, 15, I think.
ठीक है. So you did one by efficiency. I mean, you did it. Okay.
Yeah.
Huh.
So
So
this
are you
is
saying that there are just two ways of solving sums like this, and this is one of the frameworks for
this is
questions
one
like
of the
this?
frameworks. Yeah.
ठीक है. तो
In
दो
this
में ही पूरा
framework,
हो जाएगा.
हाँ, दो फ्रेमवर्क में सारे वर्क टाइम प्रॉब्लम्स हो जाते हैं ऑलमोस्ट कवर.
अच्छा.
Yeah, that's the best part. Now, it's the only thing is you should be able to realize when to use which framework, what is convenient when.
हाँ.
In this first framework, which is method one, please note work is taken as unitary one.
Hmm.
Okay. Now, moving on to the second framework, I'll have to do it on a separate slide. I'm going to copy here. Now, what we have here is method 2 again uses the same work is equal to efficiency into time. So I will write work efficiency time. Yeah. And same thing. A is 75, B is 50, and A, B, C altogether are 10, right? This is
Hmm.
minutes. This method utilizes, so gets rid of fractions. So if you don't like fractions, if you don't want to see fractions, you don't like working with fractions, then we use this method. In this method, what we do is we set time, we set work or assume work to be the LCM of times.
Oh, that one. Okay. Okay.
Yeah, which means here I can assume W to be 150. LCM, or you can take a multiple, convenient multiple. So I'm taking 150, work is 150. So let me write 150 each. Yeah.
Hmm.
So if 150 is the work and time is 75, can I say efficiency is 2?
Hmm.
150 by 1 by 75. Similarly, here it's 3 and here it's 15. Yeah. Now we know A, B, C's efficiency combined is 15. So C's efficiency will be 15 minus 5, which is 10, correct?
Mm-hmm.
Work done is the same 150. So time taken by C is 150 by 10, which is 15. See how fast this is.
Faster.
Method 2. I personally love this method. No fractions, easy on the eyes, easy to solve. We
Hmm.
have to be slightly careful in using this approach if the work is not changing.
Hmm.
If the work changes, then we'll have to be careful with this method. I'm not saying it's not useful then, it's definitely useful everywhere, but we'll have to be careful. But your work is not changing, work is the same everywhere. And the only thing which is unknown is time for C.
Hmm.
So how fast this is gets rid of fractions, and we are working with integers more often than not.
Hmm.
Make sense?
Yes, this makes sense. Okay.
Yeah. So two methods. I'll go back to the previous slide again. One method in which we take work as unitary, which is one, and then we find efficiency in terms of a fraction, and then we work our way around with what we want and what we have.
Okay.
And method two is set up work as the LCM of times, which is convenient. Find the efficiencies, which are generally integers.
Hmm.
And this is easier on the eyes and also easy to calculate.
Okay.
Yeah. So these are the two frameworks. Okay. So with this, let's move on and try some other problems. And I'm going to have our clock back.
Okay.
Yeah. Next problem. So you can try this.
Artha finishes painting the room. What is the ability? Okay. Mhm. Yeah, I got something else. How do you do this?
Oh, none of the answers match.
Mm-hmm. How long will it take to clean the room? So I need to first calculate efficiency. That is work
Yeah.
upon time. So 3 by 7 divided by 4.5. Right.
Yes.
That's 3
Yes.
by 7 into 100 by 45, which is 100 by 63. But then, uh, how does that tally with any of these answers?
Okay. Let's take a step back. Work is 3/7 completed in 4 half. Now everywhere we have fractions, so I'm not going to convert into decimal. I'm going to retain fractions 9/2 and
Oh, 9 by 2.
efficiency. Yeah, efficiency can I say is work divided by time. So it's 3/7 divided by 9/2. Yeah. Then they're asking if Martha finishes the painting the room at the same rate, how long will it have taken her to paint the room, entire room? So can I say what is the time taken for work equal to one, right? Obviously,
Seven
efficiency
and a
remains
half.
the same. Yeah, efficiency remains the same.
Uh,
So time will be what? This will be
8 and
nothing
a
but
half. Mm-hmm.
1 divided by efficiency, correct? Which is 1 divided by this 3/7, and then 9/2 goes in the numerator. And this is 21/2. So 10 half.
Correct. I think I took it as 4.5. That's why it went wrong. Mm.
Maybe. So if we have fractions here or improper fractions, then we don't convert into decimals.
Mm. Okay.
Yeah. So this was another problem. It's okay, right? So this is understood, right?
Yeah. Yeah.
Yeah. So find efficiency,
But
apply.
1 second. Efficiency will be 3 by 7 divided by 9 by 2, right? That's 3 by 7
Correct.
into 2 by 9.
Yeah. 9/2.
That is 2 by 21, no?
2/21 is the efficiency, but we want time. So time is
Acha,
1
oh.
divided by efficiency.
Oh. Oh,
Yeah.
oh. Oh. Okay.
So we need time, right? Work is 1. Efficiency is this fraction, fraction of
Okay.
fractions. So time will be 1 divided by efficiency. Efficiency will be
Okay.
plugged in and it's reverse.
Okay. 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 I got
Yeah.
it.
Yeah. Next. Okay. Why don't you give it a shot?
Oh. I'm getting 500.
Yeah, that's correct.
Correct?
Fantastic.
Oh, okay.
Yeah, yeah.
500.
Yeah. So, okay, I think this is what you must have done. We have A, information of A on A, 60 bottles, right? So that is work. 12 minutes is the time. So efficiency, can I say, is 5. Time is in minutes. Efficiency will be in bottles per minute,
Mm.
right? Now for B, it is 120 bottles every 8 minutes. So can I say efficiency is 15? Now when A and B work together, efficiencies are added up. So 20. Time asked is 25. Into will give you 500 bottles.
Mm.
So that's the answer. As simple as this.
Okay.
So as you can see, once we start using this table frequently, it's all about matter of just plugging in. It becomes very easy.
Mm.
So almost every time, speed, distance, and work time problem can be solved using this.
Okay, I used the first method.
Oh, you use the first work equal to 1 you used.
Huh. Acha, no, I did
Okay.
this only. I did this only. I calculated efficiency as W by
As
T.
5. So this only you did then. Yeah.
This only I did. So this only.
Yeah. So you use, see,
Acha,
we'll have to use work equal to 1, no, when work is not
when
given.
when the work is acha, not given or whether when
Then
it's constant.
we use W equal to 1, or we use W is equal to LCM of times.
Huh.
Okay. So see, just a few step back, few rules regarding the usage. Now, when times are given, we will most probably use work as LCM. Okay.
Mm.
Second scenario will be where work is given, right? So can I say again, we will use method 2,
Mm.
right? Third scenario is where work not given and work is constant, which means unitary everywhere. Then we will use method, or we can use method 1 there, or method 2 also. Yeah.
Okay.
So for instance, in this problem, work was already defined differently. 60, 120. They're also asking for how many bottles, means new work.
Mm.
Then we shouldn't use method 1.
Mm.
Yeah. So when work is given, we should use method 2.
Mm.
Yeah. So another problem. Let's try this.
Okay.
And once you read it, can you discuss with me whether you'll use 1 or 2?
Mm. He working alone. He can build one house in 4 hours. Betty can build one in 3 hours. एलसीएम से भी हो सकता है ना? B
Yeah.
plus C. If B and C work together, they can build it twice as fast as this guy. Okay, so but I want to use LCM, I think. 1/2. They think they build it twice as fast as him. How long will it take this guy to? So 1/4 plus 1/3 plus 1/C is equal to 1/2. So 7/12 plus 1/C is 1/2. We can twice as fast as I don't know. So 1/12. Okay, this is not working out. I'm getting a minus answer, which is clearly wrong.
Yeah. Try it again. That's okay.
Do it twice as fast as this guy. So I say 1/4 is 1/3, the 1/C is 1/2. 7/2 is 12. No? Maybe try LCM method. Oh, no. Okay, I know I did wrong. 1/3. 6, no, it is.
Yeah, it's 6.
Yeah, I added all the three instead of only B plus C. I thought it was all the three together. That's why I went wrong.
Okay. BC together. Yeah,
B,
yeah, yeah.
C. I did A plus B plus C, so I was getting a negative answer. But
Wait.
how will I do it with LCM is what I want to figure.
Hmm.
4,
So
3,
let's do
so
with
LCM will be
LCM.
12.
Yeah,
And then
work
this
can
will
be
be
12.
3, 4, total will be 7.
Yes.
Mm.
12, 12, 3, 4. Efficiency of A plus B is 7. But B and C are given.
So B plus C is twice as fast as, so if I,
A, which is
yeah.
6. Correct.
Huh.
So C's efficiency is 2 and work is 12. So T is 6. That's it.
Hmm.
Simple.
Oh, C is 6.
Yeah.
B plus C is 6. So C becomes 2. Hmm. Okay, that difference. Okay, ठीक है. This is simpler.
Hannah,
Hmm.
this is easier.
Yeah.
Yeah. So this is work time. I hope this is good.
Mm-hmm.
Interesting. Okay, another problem. Yeah.
It's 6 minutes to pack a box. And it takes 5 minutes to pack a box.
Now here, can you tell me which method will you use?
Um,
LCM method or unitary method?
I'm thinking LCM.
LCM should be avoided when the work changes.
Acha, because it's 110 boxes. Okay. So
Yeah.
1/6 plus 1/5, the same thing. And how much has it take to pack 110 boxes? Acha. But together, is this together? Should be together.
Yeah, yeah, together.
Okay, so then work is 110. Efficiency
Mhm.
is the sum of both, and I need to find time. 110 is equal to 11 by 30 into T. That's 300 minutes. That's how much? 5 hours.
Yeah.
Hmm.
Right. So see, once you are clear with which method to use, one or two, then it's easy, right?
Hmm.
So A is 6, B is 5. Work changes here, and hence I will avoid that and I'll use unitary method. So 1 work efficiency is 1/6, 1/5. A plus B together is 1/6 plus 1/5. Work to be done is 110, can I say?
Hmm.
So what is the time? So it's this into this. So T is equal to 110 into 30 divided by 11. 300
Hmm.
minutes, 5 hours. Yeah,
Hmm.
cool. Nice. Simple, right? So even complex varieties can be solved. So today we are not going to do the complex ones. You know what are complex ones? Uh, they could be tested. Okay, so they are not very common on GMAT, and hence I don't want to waste time right now. But for instance, very tough problems of work time could involve someone being added after a few days, another worker leaving after a few days. You know those complexities.
Hmm.
Less tested, and hence I'm not going to do it right now. But the method is the same.
Hmm.
Okay.
Okay.
Maybe I'll give one or two problems to you. You can try. If you don't get it, then we will do it in the next session. So
Hmm.
this is what